welcome. This is the first of our series of our natural resources unit, and today we're going to be talking about sustainability in our resources. So, one of the things we're going to be looking at is this concept of sustainability. And so here you see two images. This represents one day's trash at Westside High School. This was put on by our Environmental Interact a couple years back, and you'll notice that the trash bags here on the left make the numbers 350. That does not include any restroom trash or kitchen trash. What they did was they had a fundraiser and they bought new kitchen garbage bins for the kitchen, and so they were using those new bins. That's how many bins the kitchen needs for one day for our school. And the question then becomes, how much do you use and how much do you need? How much gets actually recycled in your classroom and how much could be recycled? Those are all questions that we need to be thinking about in our personal life and here at school when we talk about this concept of sustainability. So what is sustainability? This is going to be our theme for the next several weeks, and we're going to be talking about this magical unicorn term called sustainability. And sustainability is really this balance between conservation of resources and quality of life. Now, I call it a magical unicorn because you have three different aspects that have to be contained within sustainability. And in our society, all three of these different factors are going to be really hard pulls that make hitting that center target really super hard. Not impossible, but also very difficult. So what exactly is sustainability? It's a balance between people, planet, and profit. So when we talk about the social aspects of sustainability, we're talking really about the people. Does it make their life easier and more pleasant? Does it give them better quality or better relationships? So in other words, if I think it's too hard or icky, I'm probably not going to do something or buy something. And so if I don't like it, I'm not going to do it. People are lazy, people are, they just, they kind of get set in their ways and they don't want to do something, or they don't want to buy something different or whatever. That's the people aspect. The planet aspect is talking about using resources effectively and efficiently. So in other words, is it wasteful? Does it consider both direct and indirect impact on a planet? So direct is things like the minerals, the land, waste afterwards, etc. Indirect is like transport and the energy that it takes. How far did that material have to travel? What went into its manufacture? Was it manufactured using renewable energies, or was it manufactured using non-renewable energies? What kind of resources went into that? So for example, we will talk later about a water bottle. That's pretty convenient, so people like it. But thinking about the plastic that goes into that and how much energy went into chilling it before you bought it, those are all things that go into the planet aspect of that disposable water bottle. And then finally, profit. Is that product or service affordable? Does it save you money? Does it create jobs? Does it generate profit? Does it improve the economy? So when we talk about economic, if something's too expensive, people won't do it. If it's going to get rid of jobs, people won't do it. There's a lot of fear that goes into economy. And then you'll notice that where these ovals overlap, you have some different kind of subcategories. You won't be tested over those, but just know that like something that's economically good and environmentally good is a viable solution. So take, for example, composting. That's good for the environment. I don't have to fill up a landfill. It's good for the economy. I can save money because I don't have to have my trash picked up as often. But socially, it might not be good. Ew, you want me to do what with my kitchen waste? Ew. So people might not like composting. If it's socially and environmentally good, but not economically good, it's called bearable. We can handle it, but man, it's really hard. So it might be socially acceptable to drive an electric car. It might be environmentally acceptable to drive an electric car. You're moving from a multi-source carbon dioxide to a point source. So that makes it bearable, but maybe I can't afford a brand new car. And so that's a bearable solution, but maybe not one that's sustainable. And then finally, if it's socially and economically sustainable, but not environmentally, it might be equitable. That means everybody can afford it. So right now, fossil fuels kind of fall in this general area. They're socially acceptable. They're good for our economy. So they're equitable. Almost everybody can afford their electrical bill. Almost everybody can afford to drive a car or ride a bus. And so that's an equitable solution, but it's not really environmentally good. So know that almost all things are not going to fall in just one category. Most things will fall in one of these categories, and they try to get to that sustainable piece. But that's really what your challenge as a generation will be: is how do we get some sustainable solutions? And one of the factors that goes into whether or not something is sustainable is carbon dioxide. So when we talk about the planet piece here, one of the indirect or direct, and again, you won't be tested over direct and indirect, so don't worry about that. Just thinking about, it's not just about, that your t-shirt's made out of cotton. It's also the water that went into growing the cotton and all of that. So just recognizing that things are more complex than what we generally tend to think of those when it comes to direct and indirect. But one of the concepts we're going to talk about is carbon dioxide. And so it's important for us in thinking about sustainability to also think about our impact on carbon dioxide. So where do we contribute carbon dioxide to our environment? There's lots of ways. So if we look at it by industry, 38% of the carbon dioxide that you would personally generate, or that Americans generate, is from electrical power. So here in Nebraska, we get our electricity from coal. So that coal power plant that's down by the river, you can oftentimes see the plume of steam coming out of that power plant. That is that 38%. 32% comes from our transportation industry, whether that's you personally driving your car or whether that is the semi-truck that brought your strawberries for breakfast this morning. That came from that transportation industry. The next is 15% of our carbon dioxide comes from the manufacture industry. So that is manufacturing the plastic that held your strawberries. That is the new t-shirt, the new cell phone that you upgraded to. All of the manufacture industry, the stuff that we buy, that's 15% of the carbon dioxide that we contribute to our environment. 9% comes from residential, whether that is heating your home or your hot water heater, cooking, stuff like that. And then the last 6% is from other miscellaneous sources. The reason why we share this with you is because we want to know how we contribute carbon dioxide so that we can also figure out how we can reduce our carbon dioxide. So, and then it's important to know, how does carbon dioxide move through our atmosphere? So you'll see here that red arrows are sources of carbon dioxide that enter our atmosphere. Blue arrows are sinks that go out of our atmosphere. And what you'll also notice is a lot of them have a partner or a pair. So photosynthesis by vegetation is balanced by respiration by land organisms. They happen at about the same time scale, and there's a red one that matches a blue one. So weathering of carbonate rock is a source, but weathering of granite is a sink. And those two would happen at about the same time scale, and so those are balanced. One that doesn't really have a balance is volcanic activity. Volcanic activity is random, happens nearly instantaneously, and doesn't really have a balance. And then there are some other things that maybe don't necessarily have a direct balance, but kind of could be balanced. So here we have like burial of biomass, but burning and decay of biomass. Those might have a similar offset. And so what we do know is that carbon cycles through Earth systems naturally. So the sources, again, are volcanoes, formation of certain kinds of rocks, cellular respiration, decay of biomass. But then the one that really doesn't have a balance is the burning of fossil fuels and that decay of biomass. 60% of that carbon dioxide stays in the atmosphere because there is no direct balance. So because there's nothing that works at the same time scale or the same mechanism, that burning of fossil fuels is not offset. The out of the atmosphere, those sinks are things like photosynthesis. So anytime a plant takes that carbon dioxide out of the air to make biomass, that is a sink. Weathering of granite, burial of biomass, because once into the earth, it stays there unless it is burned as a fossil fuel. So we're talking deep ocean sediments here. We're talking some other form of also plate tectonic help that helps get that biomass down low. Dissolving in seawater, that's a really large active reservoir that stores carbon dioxide for lots of years, 10 to the 8th. Write those zeros out and see what that gets you. Ooh, that's a long time. And then carbonate sediments that are deposited into the ocean. So think about all those little critters as they make their seashells. When they die, that seashell isn't usually eaten, it just sinks to the bottom. And so that carbonate sediment is a really good place to try to get rid of carbon dioxide. But again, it's important to think of timescales. By short timescales, we mean minutes and hours. So things like photosynthesis and cellular respiration, those happen in the order of minutes and hours. Fires, those can happen in the timescale of hours. Volcanoes, hours. Burning of fossil fuels, minutes and seconds. Longer timescales are those other processes that take hundreds to thousands of years. So sediments. In order for that carbon to be captured in an ocean sediment, it first has to dissolve in the seawater, then the little critter has to make the shell, the little critter lives its life, and then that sediment, then it dies because it's eaten or it dies naturally, and then that carbonate, then that shell goes to the ocean where it sits there before it gets pulverized into a sediment. So that can take quite a number of years for that to happen. On land, that takes a long time because it's bacterial processes that have to process that carbon and trap it into the soil processes. And then, of course, rock cycle. That takes thousands of years. So then, I also want you to stop our video here in just a second and think about which of those are sources, which of those are sinks, and which of those are both. So go ahead, take a second and maybe think through that and stop the video here. So if we look at your list, what you come up with, I've color-coded these in terms of sinks are pink. So sediments and photosynthesis would be sinks. The rock cycle would also be a sink. It actually is both. And then sources, cellular respiration, fire, volcanoes, and burning fossil fuels. Those are all on the short time scale. So it's really important to think about which one is favored. Our short time scales are favored in terms of the carbon cycle. So what that means for us is when we're trying to achieve sustainability is we really have to be cognizant of how we are contributing to that carbon dioxide in our atmosphere, because that can make something not sustainable if we're not considering how carbon dioxide is going to be impactful later. And carbon dioxide comes into play as we start to talk about climate change, which we'll discuss next week. So again, here's another visual. I think that's a little bit more, gets to the complexity of that carbon cycle. So you notice here that it's not just a linear one-for-one kind of relationship. It's much, much more complicated. This particular image comes from Baylor College of Medicine Center for Educational Outreach. It was published by Martha Young, and the only thing I added to her diagram is this red, because again, combustion of fossil fuels is something that we can really impact as a society. It's something that we can really be cognizant of. And it also then has implications for solutions. So when we start to think about carbon dioxide in our atmosphere and how we want to impact sustainability, we really have to start to apply that to solutions. And so one of the things you'll hear talk about as you get older and hopefully maybe as you enter your vocation but carbon capture and sequestration. So what that means is to catch the carbon dioxide and hold it someplace in the carbon cycle. Those dollar signs mean right now it's expensive. The technology isn't quite up to speed yet. So one of the things that where we can capture it is in the oceans. If we can leverage that great big huge water body that we have, how can we catch that carbon dioxide there? The problem with this is ocean acidification and how we're impacting the ecology. And later in lab section, we'll do a little activity where you can actually try this yourself. And then if somehow we can capture that carbon in the rocks, because of that beautiful long time scale, if we can figure out how to capture the carbon and leverage that part of the rock cycle, we could store that carbon for a really, really long time. But again, it's a long process to get it there. So there's another $1 million you can make by what you've learned in this class. If you can figure out how to leverage that process, make it go in fast but stay there for a long time, you'd be a very rich person. Another solution is to reduce the carbon dioxide by reducing the fossil fuels we burn. So we'll talk about carbon neutral fuels. These are really important for Nebraska economy, particularly ethanol from corn. These are important because the carbon in equals the carbon out. So the plant grows and it captures carbon dioxide, and then when you burn that ethanol, it puts the carbon dioxide back into the air. Other things we'll talk about in the future are low or no carbon dioxide alternative fuels. These are things like wind and solar that don't produce carbon dioxide. And then finally, another thing you can do for a solution for carbon dioxide in our atmosphere is change how you use electricity. So things like avoiding peak hours, so trying to charge or use your appliances overnight rather than during the evening hours when everyone's getting home from school and work. Or reducing your use. Using natural light rather than LED lights, or LED lights rather than CFLs, or CFLs rather than incandescent. This is one of the reasons why we keep the lights off in 305 most days, because we are trying to do what we can in terms of sustainability of our school. So that is our first concept of sustainability. Hopefully, you're starting to understand or get an idea for what sustainability is and why carbon dioxide is important. You will now be starting to think about how this relates to our engineering project. And so there's a separate YouTube and a separate PowerPoint for that. Thanks, Warriors.